Hello, everyone. I'm Peng Gao, a postdoc researcher from University of California, Berkeley. I'm very honored to be here to present our demo on designing systems to enable real-time abnormal system behavior detection for enterprise security. This is the work that I did when I was a PhD student at Princeton University, in collaboration with my PhD advisors, Professor Pratik Miko and Professor Sanjeev Kuhani, and also folks from Case Western Reserve University and NEC Labs America. The full paper has been accepted in Usenix Security 2018. As we all know, today, computer systems are widely deployed to manage the business in industry and government. Ensuring the proper functioning of these systems is critical to the execution of the business. However, more and more cyber attacks made into the breaking news, and the damage inflicted by these attacks is becoming more and more severe. For example, the Equifax data breach happened in fall 2017 has exposed the sensitive personal information of 143 million US customers, nearly half of the US population. Many other well-protected businesses suffer from significant financial losses due to these attacks. The advanced cyber attack involved in these large data breaches are so-called APT attacks. These attacks leverage sophisticated techniques to exploit multiple vulnerabilities of software applications to compromise enterprise computer systems and steal valuable information. As these attacks usually involve multiple software applications and require multiple steps, we need solutions that can record all the behaviors of the installed software applications and connect multiple behaviors to counter the attacks. In order to monitor the behaviors of all applications, we leverage the idea of ubiquitous system monitoring, which collects information about system calls from kernels. System monitoring produces audit logs with a unified structure for all the applications. These logs record how applications interact with system resources, such as processes, files, and network connections, providing a global view of software behaviors in the systems. By parsing and analyzing these logs, we can connect multiple behaviors through their interactions, such as a process talk to another process via network connections. As fighting against APT attacks is a time-critical mission, we need a real-time detection tool to search for virus damaging needles in a very large haystack, for preventing additional damage and for timely system recovery. Achieving this goal requires us to address two major challenges. First, APT attacks exploit different vulnerabilities, which often exhibit different abnormal behaviors. Countering these attacks effectively requires our tool to support a broad range of abnormal detection models. Besides, system administrators, security analysts, and data scientists have extensive domain knowledge about the enterprise. A key question is how we can provide a real-time tool to detect anomalies while incorporating the rich knowledge from the experts. Second, system monitoring produces huge amount of daily logs. This requires efficient real-time data analytics on the large-scale system provenance data. Unfortunately, none of the existing systems provide a comprehensive solution that addresses both of these challenges. These systems focus on detecting specific anomalies, and the user can only influence the formulation of the model through a limited set of parameters, which provides limited flexibility for the user to incorporate expert knowledge about the domain. Besides, these systems are designed to work with general-purpose data streams, thus missing the opportunities for further optimizations based on domain-specific characteristics. Recognizing the limitations, we design and build a normal system that enables real-time abnormal system behavior detection by querying the real-time stream of system monitoring data. To address the first challenge of expert knowledge incorporation, our system provides an expressive and concise domain-specific language, stream-based anomaly query language, that integrates a series of novel critical primitives, which enables security experts to easily incorporate their domain knowledge as a wide variety of anomaly detection models in the form of continuous stream queries. To address the second challenge of timely big data analytics, our system provides an efficient query execution engine that checks the anomaly detection models against the stream of system monitoring data by executing the stream queries. Different from existing systems, the query execution engine in the SAQL system employs novel optimizations that are tailored to the domain-specific characteristics of the data and the semantics of the query to further speed up the query execution. Here is the architecture of the SAQL system. We develop monitoring agents based on existing mature monitoring frameworks and deploy them on every host in the enterprise, including Windows, Linux, and Mac OS operating systems. These agents will continuously collect critical attributes about system entities and system activities. The data collected from different agents will be aggregated together, forming a data stream. Our domain-specific query language provides an expressive and concise syntax that uniquely integrates a series of critical primitives, which enables security experts to easily incorporate their expert knowledge to query a broad range of attack behaviors. In our full paper, we categorize the type of anomaly models supported in our domain-specific language in 4 classes. The rule-based queries specify the fixed rules to query a specific pattern of system events. Time series anomaly queries specify the differences in the temporal dimension to surface the anomalies. Invariant-based anomaly models specify some system invariants. For example, a certain process may only access a fixed set of other files. But if one day this process accesses an unexpected file, then the security analyst may specify this behavior in a query to surface these type of processes up. And outlier-based anomaly models further specify the differences or outliers in terms of the properties. For example, on a database, then one type of attack behavior that could happen is the data exfiltration, which indicates that within some limited restricted amount of time, there will be a huge amount of data transfer to some external IP address. And we can specify this behavior in a query. Basically, we can aggregate the amount of data transfer for each IP address per each process on the database server. By comparing the aggregated data, we can immediately surface the outliers, and the alerts will be then reported for further analysis. Our query execution engine leverage normal optimizations based on the domain-specific characteristics of the data and the semantics of the query. And also we did extensive evaluations on 150 hosts of AEC labs. We measure different characteristics and properties of the system. So if you are interested, feel free to read our full paper. At last, I want to mention that our SAQL system has been selected as part of commercialization process and integrated in the NEC's Security Intelligence Solution, which won the first place in the Town Life and Society Innovation category at CTech Award 2016. We also had a complementary work published in Usenix ATC 2018, which we propose a domain-specific query systems on the historical data. Basically, from the historical data, all attack footprints are logged in the system monitoring events. And we can further query the massive data by surfacing out the attack footprints and connect them to provide a further context for the alerts that we detected. Together, our two systems work seamlessly for enabling effective and efficient APT defenses. I will just conclude my presentation for now. Following, please take a look at our demo video, which we show the semantics of the 4 types of the queries using a command line interface. Thank you.